Hi everyone, welcome to my channel. This is Quantum Unicorn. The problem we are solving in this video is valid palindrome. First, let's take a look at the problem statement. We want to determine if a given string is a palindrome. A palindrome is a word, phrase, number, or other sequence of characters that reads the same forward and backwards. The intuition behind this very simple and concise solution is that by removing non-alphanumeric characters and converting the string to lowercase, we can simplify the problem of checking if a string is palindrome. Then, by comparing the string to its reverse using the slicing syntax S square brackets, double colon, and -1, we can determine if the string is palindrome in a straightforward and efficient way. Now, let's go through the code line by line. First, this line defines a class called solution with a method called isPalindrome. The method takes a single parameter s of type string and returns a Boolean value. The first thing the method does is convert the input string s to lowercase using the lower method. This is because we want to ignore case when checking for a palindrome. The next step is to remove all non-alphanumeric characters from the string using the filter function and the isAnum method. The isAnum method returns true if a character is alphanumeric and false otherwise. The filter function is used to apply the isAnum method to each character in the string and remove all characters that are not alphanumeric. Finally, the resulting characters are concatenated into a new string using the join method. The last step is to check if the resulting string is a palindrome. This is done by comparing the string to its reverse, which is obtained using the slicing syntax. The slice notation means take all the elements of S in reverse order. If the reversed string is equal to the original string, then the input string is a palindrome and the method returns true. Otherwise, the method returns false. This solution has a time and complexity of O of n, where n is the length of the input string. The filter method removes all non-alphanumeric characters from the string in linear time. Then, comparing the resulting string to its reverse takes linear time as well, resulting in a total time complexity of O of n. The space complexity is also O of n, since the filter function creates a new string to store the filtered input string, which can be as large as the original input string. Overall, this solution is both time and space efficient, making it an optimal solution for the valid palindrome problem. Alright, that's all for today. I hope this was helpful. If you have any questions, please leave a comment. And also, please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Happy coding, and thanks for watching. Goodbye.